So the benefits that cloud has to offer are very well understood. And in today's session, I won't be boring you through those details. Instead, the focus of today's discussion is how you can leverage cloud-native patterns into your application code. If you look at the traditional approaches to cloud migration, they have been either design and build cloud-native applications from scratch. So this way you can really leverage the benefits that the cloud has to offer, right? But what I would submit to you is, can you afford to simply walk away from the investments your enterprises have done in their legacy applications? Over the years, enterprises have invested millions of dollars in designing, building, and stabilizing the application code, Java, .NET code, right? So the other approach to leverage on those assets is a lift and shift approach, right? In which you migrate your application code to a compatible cloud vendor. But what I would submit to you is, with this, you can take benefits of the advantages cloud has to offer in terms of flexibility, disaster recovery as a service, and savings. And everybody likes savings, right?
For sure, don't we? My clients love savings.
Yep. But then, are you able to maximize on the savings the cloud has to offer? Especially, in today's environment where IT is still being viewed as a cost center, right? So what are the benefits that you're leaving on the table? For example, are your applications really able to maximize on, scalability, flexibility, performance that the cloud has to offer? Like, if you see the session, containers as a golden hammer from Tracy, right? So one area that we'll be talking about is, the metered or dial up, dial down feature that the cloud has to offer. Now imagine if your application code is saving files in its local file system. When you bring down the VMs, do you risk losing transactional data? Right? Imagine, if your application is storing state information in its session, when I bring down the VMs, do you risk end-user session disruptions? So what is the other approach to migrating to the cloud? So in the next slide, I'll share with you some interesting facts and then get into that approach. So if you look at the code base for cloud-native programs out there, it is tiny as compared to the amount of legacy code out there. Even today, the number of lines of COBOL code is much larger than all other programming languages out there. And then if you look at the amount of Java, .NET code out there, there's still a significant code base of these legacy application codes. Imagine an approach where you could leverage cloud-native patterns into that code base, into your Java and .NET code. So there are three questions that come to mind. Is there a formalized, standardized list of anti-patterns that I can look for in the application code? How do I effectively look for those anti-patterns? Because in the absence of a repeatable way, if I have to manually look through millions of lines of code, it is error-prone. It requires huge effort in terms of months. And then, in the absence of a formalized approach, the results that you'll get are a Hail Mary at best. The third question is, before I start on this potentially long, expensive exercise, is there a way I can get early insights into the quality of the code, right? Into what is that level of funding required? So in our next few slides, we'll be talking about how to approach answer to these three questions. The first question, is there a formalized, standardized list of anti-patterns? We found it most difficult to answer. I really started with a blank piece of paper and started thinking through what are those anti-patterns out there. And then as I thought more about it, these anti-patterns, what are the different categories that they fall under? Right? And really, as I thought more about it, these are the 6 categories that came out of it. Scalability, portability, performance, availability, code quality, vulnerabilities. And if you attend the next session by my colleague, Charles Chow, he talks about function as a service. And you'll see a close match among the categories that he talks about versus the categories that I have listed here. What I submit to you is, as you think through this, right, I'm pretty sure, as you noodle more over this, these are the categories that will bubble up, because really they form the primitives of a cloud-native environment. The next thing is, I worked closely with some of the smartest engineers in our firm, looked at experiences from large cloud migration projects that we have done, and did detailed industry research to come up with about 800 cloud anti-patterns. I then sharpened my pencil and pared that list down to 120 Java and .NET anti-patterns. And then standardize that rule set to Heroku's 12-factor application methodology with focus on cloud-native programming principles such as session statelessness, a services-oriented architecture, ephemerality of compute and storage, and then extended that further to these categories that you see here. And then as we go through the subsequent slides, the next few slides, my colleague Sean will be going through each of these categories, what our interpretation of these categories is from a cloud native standpoint, what are the kind of issues with examples, right? And what are the remediation steps that we would take to address those issues. Sure.
Thank you, Vishal. So before I get into that, I'd like you guys to kind of bear with me and work through an analogy a little bit here. So if you think, as you were a kid, when you consumed a watermelon, right? You had different ways to consume that. You had a kid that he couldn't wait to get that first slice, and he'd just start diving in, right? And he forgot that, hey, there's seeds in watermelons, right? Then you have another kid who really just was waiting. He doesn't really like seeds. He already knows that they're there, right? So he's very cognizant of those seeds. And he'll sit there and kind of go through around that nice slice and make sure he can pick off all those seeds. And then he'll start eating. He'll go about halfway through that slice and realize, oh, man, there's like 5 or 6 more seeds in this slice. I'm already halfway through. So he'll, again, kind of pause, take his time, and go through that, pick out those seeds, right? And then continue eating that slice. So I take you down this path to kind of relate that back to kind of this concept of cloud deployment, right? I can take my application, that's a legacy application, and I can shove it up in the cloud, and I can let it run, and I can work through all those seeds or all those issues that come up that I don't know about, right? Or I can be a little more proactive because I know there's going to be issues, right? And I can have some sort of way to methodically go through this application, that being a legacy application, roll up my sleeves, dive into the code, because I actually went to Vishal and Sean's talk here and understand that there are some issues with statelessness. There might be some things I need to do, maybe an F5 on for a system.io or a system.threading, or maybe I need to look for some hard-coded values, maybe IP addresses. So I kind of do that, right? I get through my code, I do some changes, and I deploy that back up. And so, that's great, but there's this cycle, right? How do I know I got everything? I don't know what I don't know, right? So the next piece of that, if you kind of go back to eating that watermelon, wouldn't it be great if I had a seedless watermelon? I mean, seriously. And up until a few years ago, I didn't even know these existed, but they have seedless watermelon. You can buy a watermelon that has no seeds. So you can cut this watermelon open, and yeah, maybe there's these little white seeds that you kind of can work through and crunch through, but more likely, you'll get a watermelon that has absolutely no seeds. So if you kind of roll that back to our deployment, our goal here is to be able to prevent the work, the lift, to kind of run through your code, knowing what you don't know, trying to look for these items, right, to work towards that seedless watermelon or that issueless application to kind of before I deploy it, right? So hindsight's always 20/20, but the idea is to mitigate what we can. So with that, we'll go to the next slide here. And just to kind of ground you on the slides, on the left, you're going to see the 6 metrics that Vishal had kind of run you through initially. And on the right, you're going to see that the key quality attribute, looked at my head. The key metric is on the right with a definition. Obviously, these are very concise, tight definitions. We don't want to argue about those, but this is the definitions we're using. And then 2 example rules. Now, given the time, we're only going to really go through maybe 1 rule per slide, give or take. So this one's portability. So it's the ability to seamlessly port an application from one platform to another. So I want to be able to move my application, right? And so there's some things that can prevent that, right? We heard session state is one of them, right? It could be technology. It could be a framework. It could be a hard-coded IP. In this case, the first one I'd like to review with you is the Inline Sequel. So the first one here where it says found instance of database operations within the code base. This is where you have Inline Sequel. I'm really tightly coupled to that, right? Consider using an ORM where I can extrapolate that out. The other here is the hard-coded locale. So in this case, it's really referring to I'm trying to access a file or a network drive, and that's there. So if I port that application, guess what? Those don't work anymore, right? Next one is performance. So the ability to maintain an application responsiveness under increased load. So again, why we go to the cloud, right? This as well as availability and some other things, but performance. How can I ensure performance? So one of the things that you'll hear in the .NET world is managed code versus unmanaged code. So managed code gets handled by the garbage collector, and unmanaged code does not. So one of the things you have to do is you have to make sure you reclaim your resources based on when you're using unmanaged code. This one is referring to that. So the concept is to be able to go through the code and identify areas where you did not dispose properly of unmanaged code, and to give you a remediation that says, hey, here's how you might do that, right? The basic is I implement, I dispose, and then I have to have a finalizer if I have any fields that are used by that. Moving on to the vulnerability, right? So this is talking about the capability of a system to prevent malicious or accidental actions outside of the design usage, right? So this is vulnerability scanning, right? And there's a whole bunch of tools that do this. This is really specific to design. So there's two items here. The first one I think is pretty easy example, right? It's where I'm not using HTTPS or SFTP. In some cases, you'll see in configuration, or even sometimes in hard-coded legacy apps, you have URLs that are HTTP based, right? Where you'd want to use HTTPS. Additionally, the last one is probably the most important one. This one is system.load. So this is a Java syntax here, but same concept in .NET, right? The ability to dynamically load an assembly or a binary at runtime, right? So you're basically passing a path to a binary and loading that at runtime and doing some work. The issue here is, right, if I don't sanitize that path prior, I could be loading up a malicious binary. Right? So the code will actually be able, the tool will actually be able to identify these areas and say, hey, look, you need to go validate that you're actually doing inspection here. The next one is scalability. So this is the potential of an application to accommodate a range of capabilities. Right? So basically, how can I scale? Right? We're going to the cloud because we want to scale. Right? So I've got 3 services. I get a lot of load. I need to scale out. I need to introduce another service. I've got 4. One of the things we commonly see, right, is to Vishal's point earlier, was the 12-factor app really says, hey, we need to build stateless services. Now, that's not always true. Sometimes you need to maintain state. And what you'll see in a lot of legacy applications is they did maintain state. They maintained a lot of state, right? And in the .NET world, that is the HTTP session state. In the Java world, that's just HTTP session. But the concept here is that you're using in-process session state instead of out-of-process, right? So when going to the cloud, if you do need to maintain state, you want to use out-of-proc, right? Out-of-process. So that's a session server, or that's a database if you're doing some custom session, right? It's not in-process, okay? Because when that server goes down and that user's on server 1, and then server 3 comes up, guess what? I have no idea where that person left off because it's in process. All right, code quality. This is a measure of an application's code in relation to technical debt. I'll just focus on the last one here. I think this one's a really important one. It's called basically this is exception swallowing, right? So I'm not catching my exceptions, right? The application is just swallowing them. So they're not bubbling up. So I don't really know what's going on. Now, that's interesting debug situation, right? Now, when I'm on-prem, it's a little bit easier to deal with. When I'm in the cloud, debugging and monitoring and logging, all these things become more complex. There's tools and things to use out there that make it better, but it's complex, right? So I don't want to be swallowing my exceptions. We'll hear later in the availability why this is also important. So availability, which is the last one we're going to talk about here, this is the ability for an application to code to mask service outage faults. So basically self-healing. Right? So whether I have a fault and I need to circuit break it, or I have a service that just crashes and I need to spin another one up, right? The idea is that I can spin these things up quickly. There's some things that kind of can prevent that, right? One is hard-coded IPs, which we talked about a little bit earlier. anytime I'm spinning up new instances in environments, those IPs are going to change. So if I set a static IP, that's really not going to work, right? So a couple situations here. You can use DNS, or you can use, when you got to go to do your auto deploy, you can actually register that IP with infrastructure in an automated fashion. Okay. The other one here is local files. So detecting where I'm accessing local files. So an example here would be I'm logging, and for whatever reason I'm logging and persisting my logs to that instance, right? So if that instance goes down, then guess what? I lost all my logs. So I don't know why that instance went down. So you need to put your logs to a more persistent cloud state, right? The other option here is that you can use the fire hose in log shipping, right? There's a lot of cloud frameworks that support this as well. All right, I think, Vishal, that's it. If you want to talk about the automated code analysis in more detail.
Sure, thank you, Sean. So this brings us to the next question, the second question. Is there an effective way for looking for anti-patterns in your application code? Because if you are searching for them manually, it will take a lot of effort, lot of time, it will be error-prone, and the results will be scattershot at best. Right? So what we realized is automating the source code analysis process using static code scans will help it make a very cost-effective approach. It will bring repeatability and formalize the search for anti-patterns in your application code. So Deloitte's Storm Fury tool automates the scan of your code base. It goes to millions of lines of Java and .NET code in minutes, and it is able to tell you what are the potential issues across the application code. And as we'll talk through our case studies in our later slides, it tells you how to remediate those codes, what are the number of, what are the different categories that these issues fall under. And that goes back to the watermelon example, Sean, that you mentioned earlier. Tell me, what are those different issues in my, or seeds in this case, in my application code. So with this, we come to the last question. How can I get early insights into the level of effort that is required to remediate those issues? So we saw the need to build those custom dashboards in which we can channel the findings of the Storm Fury. And this allows us to give you code-level insights that will be valuable across all the levels of the IT organization. So let me walk you through those. So at the IT leadership level, right, using the tool, we are able to categorize the number of issues by a category, right? And what is the effort level it takes to remediate all those issues. So if you think from a business standpoint, not all these categories that I called out earlier may be most immediate for your business. For certain businesses, scalability and performance may be their key business driver. So if they want to focus on that, what are the issues that they want to remediate along those lines? Availability or performance, they may choose to address later. Right? So by sharing those insights early, we help the IT leadership communicate effectively with their program sponsors on the level of funding and the timeline that is associated with identifying or meeting their business requirements. At the technical architect level, the code scan tells you exactly what is the complexity of your application code. So Laurie is going to present a session, I think later today or tomorrow, on microservices architecture, right? That's another key push that we are seeing, right? By looking at a module level, right? What are those areas that you want to prioritize for refactoring, understanding, what is the complexity of the code, what are the issues to be addressed in that, helps in the refactoring exercise as well for application architects in the team. And at the developer level, it tells you exactly which line of code has an issue, how to remediate those issues. So if by integrating Storm Fury into your continuous development, continuous integration process, you are able to really shorten on the feedback loop associated with identifying these issues and addressing those issues. So as in the next slide, I think we'll be talking through different case studies. We have used this product at numerous clients, right, across industry clients across the globe, right? And we can go through some of those case studies out here.
Sure. Thanks, Vishal. So I suspect many of you, like Vishal and I, have a reason why you kind of gravitated to technology, right? Is it like that I like to build tangible things, I like to solve complex problems, or maybe it's just that I like to continually learn, and I like shiny new tools and architectures and all these great things we get to play with all the time. But at the end of the day, those things kind of change. But there's one thing that we've kind of found that's been pretty consistent that hasn't changed, and that is the ability to transform a skeptical client to a believer. So you get kind of some satisfaction out of that, right? I mean, we get satisfaction when we figure out some complex problem, but the ability to transform a client that's skeptical about something and make them a believer is a pretty powerful thing. And I think that kind of goes with our first case study here. Vishal and I worked with a very large global financial firm, and their goal really was to accelerate their adoption and movement towards AWS, and then really figure out how do I create an adoption policy for moving to the cloud. They have a very large portfolio of legacy applications, and they really didn't know where to start, right? So we had a conversation with them, and that initial conversation was a deck similar to this, not the same, but similar to this. We had a conversation of what we could bring to the table. And you know, there was initial skepticism, right? They're like, wow, this looks like a little smoke and mirrors. Does this really do what you say it does? And then, you know, we had a follow-up demo in the conversation with them, a little more detail. We're able to walk them through the tool and kind of the output that they could expect to see. And they were like, okay, let's give this a go. Let's run through this. So we worked with them and actually did a proof of concept with one of their applications, about a 350,000 line application, roughly. And we ran the tool, and it identified roughly 1,000, a little over 1,000 issues, or seeds, if you go back to my watermelon, issues. And they were able to basically, like Vishal had pointed out earlier, prioritize, okay? Before, they didn't really have any insight kind of what this code base was, right? All their legacy knowledge holders were gone, so it's not like they're going to roll up their sleeves and they're going to dive into this application. They really need something kind of, give me a heads up what's going on here. So they had some visibility, they were able to prioritize, and they really attacked the key critical ones initially, but then they also were able to integrate this in, like Vishal had said, into their overall process. But I think the key thing here is that, again, we're able to take a client that was pretty skeptical, right, in initial conversations, and run them through a demo as well as kind of a proof of concept within one of their own applications. And they came out and said, hey, this is pretty powerful and useful tool.
Right, and Sean, at a personal level, it was very satisfying to get validation of the ideas that we were thinking through. This was our first client, right, the external client that we had worked with. There's another couple of case studies that I want to walk you through. The second one is a global foundation for a large life sciences and healthcare organization wanted to migrate their application which supports their research and development operations into the cloud. So a early scan using Storm Fury told them what are the areas or barriers in their application code which are stopping them from migrating their application as is into the cloud. The area that they found most interesting were the performance issues in the application code. And exactly those issues, the iDispose issues that we had talked about, Sean, those were the kind of issues that they gravitated towards from a prioritization and resolution standpoint. Another case study is for a large health and human services client, where the project team inherited a code base of unknown complexity, right, as part of a transfer solution from another state. And they were given two key asks: rapidly migrate my application to the cloud, and second is customize the application to meet some urgent legislative requirements. So a scan using Storm Fury told their application architects the areas in the code with high complexity. And actually, I really want to share a specific example out here. In life sciences and in health and human services, there's a module called eligibility services. And this is a classic service, if you think from a microservices standpoint, which has this short period of high usage, where there's a surge in usage, and then there's an extended period of low, comparatively low, or typical usage, right? So the architects knew what is the code, what is that particular module they want to refactor. But then, using the scan, they were able to quickly understand what is the complexity in that refactoring effort. What are the kind of changes that they need to apply to that application code. The release management team on that project integrated Storm Fury into their continuous integration, continuous development process. So the developers were able to proactively identify issues in the application code and quickly remediate those issues. Thanks to the plain English, as Sean called out in his previous examples, really plain English descriptions of what you need to change in the code and why. Right? So in the words of their development manager, using this tool, integrating it into their CD continuous integration process, help their developers become better cloud native developers. And then I know we are talking more from a migration standpoint, but then Sean.
Yeah, so I think we've been focused on, like you said, focused on migration, but there really is kind of a pattern here for Greenfield as well. So if you think about most of our legacy developers are going to be new to cloud development, right? So one way to accelerate and keep making sure that our code is following these patterns we expect is to continually scan that. So this also would fit into a Greenfield.
Thank you. I'll keep the conclusion short. I know we are running behind on time. So what we are seeing is cloud has become a great enabler of digital transformation. And there's a heavy push, a huge push, and that's why you are all here, right? To migrate your applications to the cloud, right? By running Storm Fury, by getting an understanding of how to leverage those cloud native patterns into your application code, you'll be able to really maximize on the benefits the cloud has to offer. I'll get into Q&A now.
Thank you, Sean. Are there any questions? We have about two minutes. Yes.
In market out there, right, there are so many tools which does whatever you're talking about. Like I have worked with many tools. One is Cast, Resharper, which is already available. Though whatever you're trying to do, right, making your legacy code to cloud ready. How is your product different from others? What this is addressing?
That's one of the key challenges that we started with. And who else has? Oh, sorry. Thank you. Who else has? So, if I can, repeat that question. What is so unique about this product? Who else is doing the same thing? And he asked, did you say Cast? Cast, Resharper, right? So yeah, so two different products. Right? Resharper from a .NET standpoint, Cast, yeah. So what we found from a Cast standpoint is, the rule space is very proprietary. It doesn't give you visibility into what are those issues out there, right? What are the kind of issues that you're going to uncover? What I would submit to you is it able to give you those code level insights, right, that help you make those early decisions? And frankly, when I look at Resharper or example SonarQube, the key problem really here is not the scan of the code, but identifying what those cloud native anti-patterns are. Because that's the toughest problem I found to address. That I could not get, based on industry research, what those native anti-patterns are. I would like to really bring this out, share with the community, right? Rather than keep it proprietary, right? How do you want to evolve and how do you want to rapidly migrate to the cloud?